Okay, now we will be talking about objective. There are three main objectives. Number one is to perform an artificial neural networks to diabetes related data sets. We will be using the diabetes data sets that we get on Kaggle. Next is to test the artificial neural network performance system in terms of handling the data set in Google Colab. And lastly is to develop a reliable artificial neural network system to predict the accuracy of the people getting the diabetes. After that, we'll be talking about the attributes in terms of the input side. There are 14 inputs that we'll be using in the datasets, which are polyphyria, polydiphin, sudden weight loss, weaknesses, polyphagia, genital thrush, visual blur, itching, irritability, delayed healing, partial paralysis, muscle stiffness, alopecia, and obesity. Next, we'll be talking about the output. For the output of this neural network program, we can predict which one of the patients will have the diabetes in the future. For the datasets that we'll be using, in the original datasets, there are 520 patients inside the datasets. We will only be using 104 patients randomized, and the other remnants, which is 416 patients, will be used to train the neural network. Lastly, we will be talking about the journal paper references. There are three journal paper references that I cited from the Google Scholarship, which are one of firstly an improved artificial neural network model for the effective diabetes prediction, circa 2021. Next is Deep Convolutional Neural Network for Diabetes Mellitus Prediction circa 2022. And lastly is the Diabetes Prediction Model based on the Enhanced Deep Neural Network circa 2020. Each of the journal paper talk about the same thing, which is the use application of the artificial neural network in terms of the diabetes data set. But however, all the outputs that all the outputs inside each article are different. Some of it achieve this type of percentage of accuracy, and some of them are different types of accuracy. For example, the improved artificial neural network, the first one, the probability of the people getting diabetes based on the data sets are 99.9% of the accuracy. And then the last one is a diabetes prediction model. The percentage of people getting the diabetes are 85% or something. That's all from me. Thank you very much. I'll pass to another presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Fadaly Sham, CA22065. Thanks to Haqiem for the introduction. So, so now we're going to move to the methodology. Here's are the few agendas. We have data processing, neural network architecture, perform training, and evaluate. Without further ado, let's begin. So in the data processing, we have two process, which is data collection and data processing. For data collection, data set was obtained from the database. Data upload CSV file, which contain record of patient along with their medical attributes, such as age, genders, and symptoms. The data will be imported using pd file name from Google Colab. The original column age shows the numerical number from 16 to 90. The data of genders are shown with the female and male, while the other attributes column shows three, either yes or no. The class attribute, which need to train and predict later on, shows in the data string positive and negative. For the data processing, the, the project utilizes the label encoder to process the dataset column that contain the values that are strings into the integer of value 1 or 0 by using the df apply. Uh, this will fit and transform the data into the data set. These are transformed into numeric representation so that the neural network could process it. The data will later shows by the data process after using the label encoder. This is the result of the data process after using the label encoder. As you can see, there's attributes and data process, which is gender, other attributes, and class. Move on to neural network architecture. The neural network architecture was created using Keras sequential model. The backpropagation will be implemented in Keras. So there will be 4 layers, which is input layers, hidden layer 2, and output layer. The description of input layer is input dimension, number of features in the datasets connected to the first hidden layer. So for the hidden layer 1, there are 64 neurons, activation, rectified linear unit. It also learns pattern from the input. In the hidden layer 2, there are 32 neurons, activation using rectified linear unit. This is for refine the patterns even more. Next, for the output layer, it only have one neuron. The activation using sigmoid produces probability between 0 and 1. Output a probability for binary classification. Output a value between 0 and 1 interpreted as a probability. Move on to perform training. There are key features that will be taken here, which is validation split, epoch, and batch size. All three of them are used to minimize the loss while monitoring the perform training. Validation splitting means that it will reserve a portion of training data. Epoch define how many times the model sees the entire training dataset. Meanwhile, the batch size controls how many samples the model processes before updating weight. In this model training, there are X train and Y train. X train contains the input features, meanwhile the Y train contains the class label. For our project, the batch size is 32, meanwhile the weight after every sample is 32. The verbose equals to 1. We will training the model using 100 epoch. Last, for the methodology is to evaluate the neural network performance. So prediction were made on the test datasets. The model output probabilities between 0 and 1, representing the likelihood of the positive diagnosis. A threshold of 0.5 was applied to these probabilities to convert them into class labels, where values greater than 0.5 were classified as positive and value less than or equal to 0.5 as negative. Performance was assessed using several metrics, including accuracy, which measure the proportion of correct prediction, and the confusion matrix, which provide detailed insight into true positive, true negative, false positive, and false negative. Loose plots were generated to visualize the model's learning process by comparing training loss and validation loss across epochs, helping to identify whether the model had overfitted or generalized well on the unseen data. Next, I will pass on to my group members to continue with their presentation.
Good morning, doctor. My name is Xiong, and my matrix ID is CD22052. So now I will be presenting the code explanation part. So first, uh, I import the pandas as PD as the library, and then I use the data frame here and insert the CSV file to be read. And here I can show the whole dataset, or maybe only the head of the dataset. So the dataset will be shown here. This is the attribute and this is the value. The value is very random, such as there are yes and no, and male and female, and this is the class for the result, which is positive and negative. And next will be import the numpy as np, which is the library, and we'll import the matplot library to use to show the graph. Next, from sklearn pre-processing, import label encoder. This one is used to standardize variable, and the label encoder is used to make the variable make the output into value, which is binary 1 and 0. So after the fit and transform, the value such as the original value male will be 1 and female will be 0, and accordingly like this. So next, we'll implement the from sklearn model selection, import the train test split. The train test split is used to divide the dataset into the training and testing. And after that, we'll use x df drop class axis1, means that the class attribute over here will be dropped. The class attribute over here will be dropped to test the whole column will be dropped. So for the y, it will be used the class that I dropped just now as the output. So now here we declare xtrain xtest, ytrain ytest variable for testing, and the test size will be 0.2, and random stat is 0. So after that, from sklearn preprocessing, import the standard scaler to standardize the variable. So after that, the TensorFlow, which is the class, will be import for the training and testing. So for the class model, we'll import the sequential model, and the dense is the layer of the model. And then so from here, xtrain equals to scalar fit transform xtrain, and xtest is scalar dot transform xtest. After that, the model will be declared to sequential, and the model at dense, which is the layer, will be 64. Activation is the rectified linear unit, and the input dim x train shape 1 means that the column that will be used every time to train is 1. This is the first layer, which means 64 neurons will be used. For the second layer will be 32. And then for the last layer will only be 1, because we want to check whether the binary value is 0 or 1. So the activation here that will be used is sigmoid. After that, the model will be compiled as the binary classification. So the optimizer name is Adam, and then the loss, which means that this how wrong is the training outcome, and this one binary cross entropy will be used to validate whether it is 0 or 1, and the matrix will be accuracy here. So we declare here history equals to model.fit, and we put the parameter inside here, which is xtrain, ytrain for training, and the validation split is 0.2. Means that the 20% of the dataset will be used to validate, and the epochs here equals to 100, means that all the datasets will be run for 100 time for training, and the batch size is 32, means that each datasets 32 datasets in each batch, and the verbose is 1. So what will happen here is if you call the feed and it slices the data into the batches, and it repeat iterating over the entire dataset for the 100 times of the epoch here. So it will be shown the training progress here until 100.
My name is Anisbussara, anak perempuan Tong, CD22081. Now I'll be presenting about the results and conclusion. As for the result here, as you can see, we have declared the loss and accuracy to test using the test X test and Y test. So to print out the test, we define it as a test loss, and using the X test and the test accuracy using the Y test to print out the results. And test loss equal to 0.0247, and test accuracy equal to 0.9904. As shown in the graphs, you can see it as the training loss steadily decreases and the validation loss remains stable, indicating there's no overfitting and the model generalized well. So after training the data, we tested the model with unseen data, and if the prediction of the data is greater than 0.5, it will label as diabetic, and if it's lesser or equal to, it is labeled as non-diabetic, and the model correctly classified the data tested, which is total of the patient that we have collected, 104 patient. And as you can see here, there's a lot of positive and negative value we declared through using the label map, which is when the result is equal to 0, it will become negative, and if it's 1, it will become so positive. So then we will print out the sample, which is equal to sample and the number of the tested patient, and also include the label negative or positive. As a conclusion, this project was developed using neural network model to predict the diabetes risk using patient health data, including like common symptoms and condition. The model trained was on a label dataset with proper data processing and tuning using multiple hidden layers with Euler activation and sigmoid output for binary classification. It shows that it improved the accuracy and reduced error during training and testing on validation data, and also confirmed its ability to correctly identify diabetic and non-diabetic cases for the patients. And last but not least, the result highlighted the potential of neural network for early medical diagnosis with future improvement possibilities by adding more patient information and using advanced model architecture for real-time healthcare application. And that's all for my part. Thank you.